This is the video tutorial for the ARC 220 Module 1 Core and Shell '04 drawing assignment. In this drawing assignment, we're going to continue to work on our Core and Shell project. This particular project is going to focus mainly on creating the stairs and all of the details that go along with those stairs. So jumping right into our Revit model here, I am going to start by placing the stair. So I go to the Architecture ribbon, go to the Stair tool. Just like any other element I create in Revit, I start by checking out my type. It is currently set to 7-inch max riser, 11-inch tread. That is code for commercial stairs, so we're going to run with that. We're going to heavily edit this type later on, but for the purposes of getting the stair placed, that should be good enough for now. Our base level is the first floor. I am on a first floor plan view. Our top level needs to be changed to the second floor because stairs, the way that stairs are created, they go from one level to another, and if you don't have the proper level set, the stairs won't reach it, or it will overshoot it. You can also see here that when we set these constraints in a stair, it shows us the desired number of risers as well as the actual riser height, which is good information to have. We come up and check our options bar. We are going to be using the center of the stairs as a location line with the 0 offset. Our actual run width is going to be 4 feet wide. We are going to keep the automatic landing checked. Basically, as we create runs of stairs, the landing will automatically be created between them. I'm going to jump here to my final deliverable. So our stairs here, just to take a look at them, they consist of 3 separate runs in a U-shape or a switchback configuration. They're in this entryway here. So I'm going to come up to my contextual ribbon and I've got all of my stair tools. The first thing I'm going to do here is click on this railing button, and I want to change the type of the railing to guardrail rectangular, and we want to place that position, make sure it's on the stringer, not the treads. The railings are automatically created when you place a stair. Let me go back to that menu. You can set this to none if you don't want a railing to be automatically placed. But the default action is to automatically place a railing on a stair. Now, the railings are separate elements than the stair, but they do get attached to the stair, so they're very closely related. We're going to come and look at our drawing tools. We are going to be creating the runs, and they are going to be straight runs. And like I said, as we create those sections of runs, the automatic landing will create the landings in between. I'm going to come somewhere around here, centered roughly on my door. I'm going to click, and sometimes you have to look really closely. There is dim gray text that says how many risers you've created and how many you have remaining. I want to create 5 risers and then click. So there you can see the designation there, the 1, the 5, so I have 5 risers. I'm going to move my cursor up and to the left so that I'm beyond existing run of stairs. I'm going to click again, and I'm going to move my cursor to the left, and I'm going to create 6 risers here. And again, I'm looking all the way over here where the text is. It's hard to show you since it moves when my cursor moves. So I want 6 risers here with 19 remaining. And then again, I'm going to move my cursor to the left and further down. And now I'm just going to move my cursor all the way past the risers to ensure that all the remaining risers are created. If you don't do that, you might not get enough risers and your stairs might not actually meet the second floor. So I'm going to click again. This is obviously not the configuration of the landings I want. If we look at my final deliverable, you can see that the landings are square. To do that, what I'm going to do is use the Align tool to move each run segment into the proper alignment, and these landings will automatically resize as needed. So I'm going to start the align command with the AL shortcut. I am going to start here with the multiple alignments. So when you check that off in this align contextual ribbon, what that allows you to do is only click the thing that you're aligning to once, and then you can align multiple other objects to that. So I'm going to align to the inside of the stringer on this run. To that, I'm going to align the top riser of this run and the bottom riser of this run. I'm now going to turn off the multiple alignment, and I'm going to align to this riser the interior face of this stringer. Oops, I didn't get that right away. Let me start that over. So this riser to this stringer, and then this riser to this stringer. And you can see what results is a square landing because I've aligned all of my edges up to each other. Now that I have the configuration set, I have to get out of my alignment tool. To do that, I hit escape twice, and then I can simply hit the green check mark, and there's my stairs. Now, I'm going to switch to the second floor plan, and what I need to do, I'm just going to grab this and drag it over here a little bit closer where we want it to be. Now that I have it kind of positioned in space here, I'm just going to use the align tool again. I'm going to click on the edge of my second floor slab, click on the top riser. And for now, we can always move this later. I'm using my arrow keys to nudge it to the right. It just needs to be between this exterior wall and this elevator shaft. It does end up being closer to the elevator shaft than the wall, so I'm just going to nudge it over about there. We will locate this entire stair to its final position once we get a column grid in a future assignment. Now, before I start making a lot of edits to this stair and railing type, what I like to do is create a view where I can see what the edits are doing to the stair so that I'm aware of the implications of my menu edits. So I'm going to start by going to my default 3D view. I'm going to right click and duplicate this view. So duplicate view, duplicate, so that I have a copy of that. For now, I'm just going to go ahead and rename this stair in my so this will be a 3D view of the stair and the stair only. To do that, I'm going to drag a selection box around the entire model, and when you do that, you could come down to your filter button here. The filter is usually a funnel icon, or even after you've selected things, you can come up here to your contextual ribbon. You have a filter button here as well. Open that up. And what I can do is I can deselect anything that says railing. So railings, railings, handrails, railings, top rails. Find stairs, stair landings, stair runs, and stair supports. I'm going to deselect all of those. I'm going to hit OK. Then I'm going to right click on one of the objects I have selected and say hide in view by elements. And what remains is all the stuff that I unchecked, which was, or deselected, I should say, by unchecking those things. And now I can take a look at this stair on a closer level to see how my edits change the stair. I'm going to jump to my instructions. So the first thing that we're going to start with, actually I've already done a lot of this stuff in the instructions. Once we have the stair placed in our new 3D view, I'm going to start with the stringers. As you can see in the instructions, we do not have the proper profile loaded yet for the stringer. The stringer is going to be a C12 by 20.7, I think it's called. That's a structural shape. Right now, the stringers are just rectangles. Before we can edit the stringer, we need to load that profile in. So I'm going to go to Insert, Load Family. I am going to find the Profiles folder. It is a piece of framing. It is steel, and you can see that we have C-channel profiles right here. So I'm going to open that up. I can find the C12 by 20.7 C-channel profile, hit OK, and that's loaded in the project now. Now that is going to be available in one of the type properties. So I'm going to select my stair, edit my type. So I want to start with my stringer. So down here you can see in the supports panel, we have the right support type, and the left support and the left support type. So we need to change our right support type. It's currently stringer 2-inch width. We're simply going to modify this type. So we're going to click here to bring up the stringer 2-inch width type. So the stringer is the family, and that's a system family. And the type is stringer 2-inch width. I'm going to rename this to say stringer C12 by 20.7, which is the profile that I just loaded. Hit OK. So we've only renamed this. We are going to change the section profile from default. The default profile is just a rectangle, and you can see here that we can determine the rectangle size with the total depth and the width. But we want to change this to be an irregular shape. We actually want it to be the C-channel profile 12 by 20.7 that we just loaded. If we didn't load it, that profile, we wouldn't see it in this menu. That's why we had to do that first. So we're going to click on that. If we look at our instructions, we can see that we need to flip the section profile. We need to change the material to this steel material. And we have to change the structural depth on the run and the landing. Let's start up here with the material. We're going to click in there and find that steel material. I'm just using this material because it's already in our template. It's not that I particularly need these stringers to be this grade of steel. It's just, it's going to give me the properties that I need. I'm going to flip the section profile. I'm going to change the structural depth to 1 3/4. The structural depth on run, I should say. On landing, I'm going to change that to 8. Now that determines the vertical placement of the stringer at those locations on a run or a landing. And then you can already see that that has changed our stringer. So we can hit OK and we can see the results in this 3D view. So now we have a C-channel stringer. So when I was talking about the structural depth, I'm talking about the height of the stringer in relation to the run or the landing. You can change those independently. So to get those to the proper heights that we want, we have to change those. We're now going to edit our run or our treads. I should pause here for a second to talk about stairs. Stairs are system families that also, like I said, get railings, which are system families, attached to them. The rails and the stairs are made up of a bunch of other families. So these are an example of nested families. So even though the stairs and the rails are system families, many of the parts and pieces of the stairs are loadable families, such as that profile that I just loaded. So that's helping me build this stair. And there's so many different parts and pieces to each of these stairs, and they're infinitely configurable. And this assignment is only kind of just touching on the basics of stair construction, stair and railing construction. They can get very, very complex very quickly. So I am going to select the stair again. And you'll notice as I hover my cursor over, it kind of flips from the railing to the stair. And if I tab in, I can even tab into the individual elements. Generally, I want to select the entire stair or the entire railing when I want to edit those types. So I'm going to edit the stair type again, bring up this menu, and now I'm looking at the run type. 2-inch tread, 1-inch nosing, 1/8 inch riser. It's basically the same except for the riser thickness. And if you look here, I only have this type, so I'm just going to, again, I'm going to rename this, and I'm just going to change that to 1/8 inch riser. The tread material, and again, this is, all of these are in the instructions, all of these properties, so check each one of these. The tread material is lightweight concrete. So I'm going to use the search tool, find lightweight concrete, hit OK. The riser material is going to be that same steel material we used before for the stringers. So steel ASTM A992. We are going to have a tread, so you can see that you can even turn the tread off and just have risers, which would kind of be silly, but you could do that. So we have the tread turned on. We have a 2-inch tread thickness. The tread profile is a default square. The nosing length is 1 inch. The nosing profile, however, we're going to change back to default. Then for the riser, we do want to show a riser. We want to show the riser as slanted, and we're going to change this thickness to 1/8 of an inch. The riser profile is also default and it extends behind the tread. And that's all the things that we need to change here, so we can hit OK. And again, you can see down here that my runs, really the entire run has changed. So that includes the risers, the treads, and all that. So now we have an 1/8 inch steel riser, we have concrete treads, and the nosing is simply slanted. It's no longer sort of a profile, it's just a slanted nosing. So I'm going to continue down in my instructions. Now we're going to get into the railings. So the first thing we need to do is change where the railing exists on the stringer. So previously, let me turn on thin lines here so this looks a little bit better. Previously, we talked about how when we created the stair, we went into the railings button and we changed that these railings are going to exist on the stringer, not on the tread. So they're going to be attached to the stringer. And this is pretty common in this is basically a metal pan stair tread where these are made out of steel metal pans that are welded together. The stringers are structural C-channels that are welded together, and then the railings simply get attached or welded to the stringers. And you can see right now that they are not centered on there, and I want them to be centered. And this is based upon, this next dimension I'm going to change is based upon the width of the C-channel, but that offset from the path is going to be -1 1/2 inch, 1.5 inches. Essentially, my stringer is 3 inches wide, and I want the path of the railing, which is the center line of the railing, to be half of that, so that's 1.5 inches. And that's why I set that railing offset to be -1 1/2. Now that is an instance parameter, so that only affects the railing that I had selected. So I also have to edit that on this railing as well. So -1.5 inches, and now those are both in the proper spot. So now we're going to start editing the guardrail itself. So we are going to go, again, we can select either one of them at this type because now we're editing the type parameters. And you can see here that we have some edits to the top rail and the handrail. So the top rail, we are going to use the top rail. The height is 3'6". That is guardrail height, or 42 inches. The type, however, we're going to change. We're going to come in here and we want that top rail to be 2 inches by 1/2 inch. Now, if I come into this profile, I'm looking for a rectangular piece. So I have a square handrail or a rectangular handrail. Basically, I want a rectangle because it's 2 by 1/2, but there's no option here. And I can't create one here. So what I need to do, and you can see this is a profile. So I'm going to cancel out of this, cancel out of all of that, and I'm going to come over here to my families in my project browser, find my profiles, and find that rectangular handrail profile. And you can see here those two options I had, 2 by 2 and 2 by 3. I'm going to right click on one of these and duplicate, and I'm going to call it 2 by 1/2 inch. And now I can right click type properties, click on type properties, and now I can edit this rectangular handrail. It's just a rectangle, so it just has 2 dimensions. I need to adjust my height to be 1/2 inch, hit OK, and now that's available for when I go back into my type family for my railing. So I'm going to edit, or sorry, my type properties, I should say. So I'm going to edit that rail again, edit type, come down here to the top rail. The type again is currently rectangular 2 by 2, so I'm going to click there. And now I should be able to find, there it is, rectangular handrail 2 by 1/2. The transition is going to be gooseneck. The material again is going to be that same steel material. Now this is the top rail, so that is all I need to do for this top rail. With one exception, I should rename this. If you change the actual profile, you should also change the name of it to reflect that. So I'm going to call this rectangular 2 by 1/2 inch. Hit OK, and again you see that reflected here in the model. We now have a 2 by 1/2 inch flat bar as our top rail. So I'm going to look at my instructions for moving on. So that was all of this stuff. So again, these are all the menu parameters for that step. Now we're going to work on our balusters. So the balusters are the vertical elements of our railing, and here are the settings for that. So I'm going to again select my guardrail, edit type, go to my baluster placement row, and hit the edit button. I'm going to expand this a bit so I can see more of it. This is broken down into a few different windows. The top window is the main pattern. That main pattern happens before the start of a railing, the end of a railing, and any corners. So corners happen like where you have a landing and you change direction of the stair. So you can change the baluster type and spacing and all this stuff dependent upon those three, I should say those 4 placements. So you have the main pattern, the start post, the corner post, and the end post. All of our baluster families are going to be the same. It's going to be that 2 inch by 1/2, only this isn't an actual profile. This is a baluster, which is based upon a profile. I'm just going to come down here, and here you can see that there is a baluster steel flat upright 2 by 1/2 already in the template. So we're going to choose that for our main pattern. The rest of this is good to go. We're going to leave our spacing at 4 inches because that is the code requirement. You can't pass a 4-inch sphere between your balusters. Start, corner, and end posts are going to be the same. We're not going to have any special balusters in here, so we're going to go with that flat upright 2 by 1/2. Now a couple other things. Again, this is why it's so important to really look at every option on here. So the break pattern at, we're never going to break our 4-inch pattern. So we're going to not say each segment and we're just going to say never. We're going to justify to the beginning, and the excess length fill will be set to none, and so the rest of this is good to go. So again, you can break the pattern at ends of segments or at specific angles. You can justify it to the beginning, the end, the center. You could spread the pattern to fit. You can do all sorts of things with this. Again, we're just touching upon the real basics of this. You can even specify a baluster per tread so that if you're putting it on the treads that you get so many balusters per tread. Our spacing of these down here is 1/4 inch for the start and the end, and 0 for the corner. So I'm going to change this to 1/4 inch and this to 1/4 inch. And that's all I need to do for my balusters. I'll hit OK, and again that will be represented in the model. Now the one thing I haven't checked is baluster material. I believe is probably done at the family level, so I might have to, I don't have this in the instructions, but if I go to baluster steel flat upright, I could come in here, go into my type properties for that, And you can see that the material right now is by category. So I could come in here and change that since I want this all to be steel and all look the same. Hit OK. And now those balusters are the same material. And now you can see that they are spaced regularly at 4 inches and the pattern doesn't break anywhere. And you can imagine that in that baluster menu that we're looking at, let me go back. This baluster, this railing is very simple. It's just a simple spacing. But when you go into this baluster placement, you can actually add profiles, add different baluster families to your pattern, and you can make very complex patterns here. So you would duplicate and you could add as many as you want in here. Again, we're going to keep with this simple type. Hit OK. Now we're going to move on to the last piece of the stair, which is the handrail. In commercial construction, because you need a guardrail at the edges of stairs, which is at 42 inches in height, which is guardrail height, you must have a separate handrail because the code requirements for the handrail are anywhere between 34 and 36 inches in height. So if your guardrail's 42, it cannot act as a handrail. So that's different than residential construction. So what I'm going to do here, actually let me cancel this and move this over so we can see this better as we do it. So I'm going to come down to the handrail section of my stair type properties. The position I'm going to leave left. That is correct. It puts it towards the inside of this stair. I'm going to click on the circular 1.5 inch. Now I don't want to actually change this to a wall mount, so I'm just going to leave it circular 1.5 inch and just rename it. I'm going to call it rectangular 2 inch by 1/2 inch. So every element of our top rail, our handrail, our balusters, they're all going to be made out of this 2 by 1/2 inch plate, or bar I would call it. The default joint is miter. The hand clearance, I have the hand clearance set at 1.5. I believe that could be wrong. The hand clearance is actually measured to the center line of the rail. So if our rail is 2 inches wide and we want 1.5 inches of clearance between it, we will need to set that to 2.5 inches actually. So let's set that to 2.5. I'll have to update my instructions. The height we'll leave at 3 feet. The profile, again, we're going to find that rectangular handrail 2 by 1/2 inch profile that we created. For the transitions, we are going to set this to gooseneck. Now that determines these transitions here at the corners. I found that gooseneck provides the smoothest transitions. Some of these others, you get some really funky results. The material, again, we're going to switch to that steel material. The extension style is going to be floor. So the code requires our handrail to extend past the last riser by the depth of 1 tread. It also states that the handrail must terminate somewhere. It can't just be hanging out in space. It can terminate to the floor, it could terminate to a wall, or it can terminate to the guardrail itself. We are going to terminate these to the floor, so that's why I've chosen the extension style to floor. The length is going to be 0, and we're going to say plus the tread depth. So that way you could put a different length in than the tread depth, but if you just click this, it's just going to extend it by the tread depth. And that meets code as well. For the top, we are not going to extend it, and we're going to leave the terminations to none. What the terminations are, you can actually load families that sort of give the railing a place to terminate. So hit OK, and you can see again that the result in our 3D model here. Now these extend past the bottom tread and they go down to the floor. That pretty much ends all of the work that I actually need to do to the stair itself. I can look at this in my first floor plan or my second floor plan and see the results. The rest of the work involved in this assignment is going to be creating the section views and the detail views so that we can further detail this stair. This is crucial because there are only so many things that you can do to the 3D model that will show the actual construction of this. For example, you can see that the transition between these stringers here is kind of funky. There's kind of some space missing, and it doesn't really make sense to me in my drawings to have to figure out how to make that work three-dimensionally. In fact, I think it's impossible in Revit to make that work three-dimensionally without a lot of work when it doesn't really even show up in any of my drawings. For example, my first floor plan and my second floor plan where the stair is so far, it looks fine. It has all the detail I need to see. I do need to show some other details, and that I'm going to do by starting to make my sections. Now, I could start placing my sections here on my 1/8 inch floor plan, but if I was documenting this building fully, I would start getting my plans very cluttered up with section markers at this scale. So what I'm going to do is I'm going to call out a new plan, an enlarged stair plan. So to do that, I'm going to start on the second floor, because in the second floor I can actually see the entirety of the stair without any of those dashed lines or anything. And actually we're going to change that in a later assignment, what we see. So I'm going to start here. I'm going to go to my view tab and I'm going to create this call out. And essentially a call out is just a rectangle that creates a new view. So if I'm going to click up here somewhere between the inside corner of this wall and the outside corner of the stair, and I'm going to encapsulate the entire elevator shaft. That looks good right about there. I didn't quite get this far enough away, so I can grab that and I can pull this up a little bit and make sure that it just wraps around my stair. Pull that over. Of course, it always places the head in some default location, so I'm going to grab that head and move it down here. Now you can find that in that is a call out of a floor plan, so it's going to show up in my floor plan section of my project browser. So you can see that here, second floor plan call out 1. You can also, if you escape out of it after you've created it, you can double click the head and it'll take you to that view, and then you can see which view is in bold, because the active view is always in bold in your project browser. So you can see here that we have a call out. Basically it's just another view of my second floor stair. I have some building sections placed, so I'm going to select that building section. I don't need to see that in this particular view. I'm going to right click, hide in view. So if you have any of those building sections created, you could do that at this point. Just hide it, we don't need to see it. The first thing I do after creating a view, whether that's with a call out, a section marker, or an elevation, is I want to change the scale, and this one's going to be at 3/8, and the detail level, this detail level for this is going to remain coarse. So I like to get my view set up essentially. Then I can start placing my sections. So I'm going to go to the section button here. That's on the view ribbon, or I could even come down to the quick access and hit the section marker button. Same thing. Section markers always start with the head, so I'm going to click here and I'm going to zoom in up here. I'm just going to put the tail just to the outside of my stair. This is facing in the wrong direction if I look at my final deliverable. So I want my section to look in that direction. You can also see in the final deliverable, we won't actually see this crop region. So a lot of times I'll just hide that, because you can see I pulled this quite far out from the actual stair in the final deliverable. So I need to hit the flip button. I also want to pay attention to this dashed blue box. That is my clip region. That shows how far I will see into the model in this view. So I'm going to pull that relatively close to the stair, and I'm going to place another section here at the top run of the stair. I'll try to line those up as best as I can. I'll leave this view extended out, and if I double click on the head, it'll take me to that view, and you can see that I am seeing the entire back wall of my building, and you can see in the final deliverable I do not see that. So that's what I was talking about with that blue line. So let me go back to my call out, select the line of the section marker, and that turns the whole thing on. So you can see if I pull this back just to be on the outside of the stair and I go back to that section, I no longer see those windows. So that controls how far I see into a section cut. I can pull this down. I don't need to see any more than the top of the rail. And again, I can set this. This one is going to also be 3/8, but this is going to have a medium or fine level of detail. I can go back to this section and I can do the same thing. Now some of this will pull from the other section. So it already knows that I want this to be 3/8 and a detail level of medium. Another good thing to do is name these as soon as you can, because if you start making all these sections, they just give them numbers and it gets very confusing. So I'm going to come back here to my second floor plan callout in my project browser, right click, rename, and call it enlarged stair plan. And then this section I'm going to rename, this is in the instructions or on the final deliverable, north-south stair section 01, and this other one is going to then become north-south stair section 02. I'm going to go to that second one. When I cut that section, it cut it all the way from the first floor all the way through the roof. I do not need that. So what I'm going to do is I'm going to pull my crop region down to just above the railing. I'm going to pull it up to a little bit. But that has an implication in another view. If I go back to my enlarged stair plan, you can see that because this was cut on the second floor and I moved the crop region of this section out from my second floor, it no longer shows up there. If I go back to my first floor plan, because I created these sections in a callout, they do not automatically show up here. From looking at the final deliverable, you know that I have to call this out somewhere. So I have kind of this, I would call this sort of an orphaned section. So what I can do is I can come back to my view bar, click the section button again, but this time instead of creating a whole new view, I'm going to come up to my contextual ribbon and click this reference other view button. And now I can choose the view that this new section marker references. So I can reference an existing view with a new section marker. And I'm going to do north-south stair section 02, and I'm going to simply recreate that section marker. I have to flip it again. I'm going to escape. This happens a lot in architectural drawings where one section is referenced by many section markers on a drawing. And a lot of times they are not exactly the same, but they might be similar, which is why it's placing this SIM on here. If we select this section marker, we can go to edit type, and here in the reference label, we can just edit that out because this one is not similar. It is exactly this one. Now, if I double click on that head, it takes me to this view. So it hasn't created a new view at all. It just references a different one that no longer had a section marker because I pulled this crop region down. So now that my two sections are created, now I can do the callouts on these sections to create the two section details. So I'm just going to do a little bit of extra work here. I'm going to get this set up. I'm going to pull my level marker out so it's not on top of the drawing. Since I have my crop region set up exactly where I want, I can go ahead and I can turn it invisible. So that's the crop region visibility. It doesn't actually get rid of the crop region, it just turns it off. Now I can come back up here to the callout, and I believe it kind of encapsulates obviously the handrail, and I think up to the middle of the second stair, and that's all we got to do for this. Again, this head will fill out when you place it on a sheet. Actually, the only other thing we need to do is add the brake lines at the brakes in the slab, and I'll show those later in this tutorial. So now we can go to the north-south stair section and do the same. We need to create a detail where this top tread hits this, or basically the top of the stair. We're going to do another call out, and we're going to draw a rectangle roughly that big. This one I'm going to have to edit the location of the head to get it in a better location, somewhere over here. Now you can see in my sections, now one thing I did wrong is I wasn't paying attention to my type, and my sections were building sections. These are not building sections. These would be considered a wall section because they don't go through the whole building. So we're going to go back to enlarge stair plan, select these. Now I don't know how this is going to work because this references the other view. These should be called out as wall sections, and luckily enough it did move both of them down here. However, the callouts are still, that's interesting, the callouts are still showing up in the building sections. Let me go check those. If I select this callout, it's calling it a building section here, so I'm going to call this, actually this should be called a detail. This, the type is a detail, not a section, even though they are technically section details. Now in this section you can see on the final deliverable that there is a break in the middle. There's a section break. So to do that, we need to break this crop region. Before I do that though, I'm going to go ahead and place my break lines first. So the break lines are an annotative detail component. So I'm going to go to annotate component, and it appears that I have one loaded already, but if you do not, go to load family. Now I'm going to navigate up to my base folder, so English Imperial. I'm going to go to my detail items folder. Anytime I start the annotative detail component placement menu and I go to load a family, I have to choose things that are in the detail items. I don't know why this is not called detail components, but it's called detail items. So you click in there, and this is broken down by division, and we are looking for, right now the break lines doesn't really fit in a division, so they put it in this division 1 general because it's not really an element of a building. So we're going to hit open. I already had one loaded in. The way that these work is you can hit the spacebar and it rotates them 90 degrees. So I'm going to click the spacebar, and I'm just going to place it somewhere on top of the stair, because the way that the break lines work, as you can see, it creates a break line, and then onto one side of the break line it creates what's called a masking region. It masks out what's behind it. So this is going to mask out whatever I rotated to, is going to mask out what's to the left. So that'll work for my right break line. So I'm going to take this break line, I'm going to move it. Let me me see what I have in my final deliverable. I'm going to grab, somewhere between the first tread after the landing. That looks good. And then I can just use these handles to extend that brake line up. You can also change the size of the actual squiggle, whatever you want to call that here. I'm going to leave those alone and just leave that right there. I can select this brake line then. I can hold control and drag it, and that will make a copy of it. And I want to be somewhere on the other side of this wall. So I'll just drag that over to there. The other nice thing about copying them that way, it puts the brake in exactly the same spot, or roughly the same spot. This one I need to bring it up a little bit further. Now the problem is this one is a copy of this one, so it's masking to the wrong side. So again, if I select this and hit spacebar, it's going to flip it. Of course, all that work I did on getting it in the right spot goes away now, so I should have done that first. Bottom can come up somewhere up here. Now that I have my brake lines in place and they're masking part of the drawing, now I can break my drawing up. To do that, I select my crop region. If you can't see your crop region, again, just click on the hide or show crop region button down here on your view control bar, and it should come up. Select it, and you'll notice these little Z lines on the edges. You want to hover over one of those on the top or bottom. That's the vertical view break line, and click it. What that does is it takes our view and it breaks it into two separate viewports. And we can break this up as many times as we want. But for now, we only need to do two. Then you can use the handles on the individual breaks or in the individual crop regions to pull that over to the other side of my brake line. That's why I like to do the brake lines first, because then I know where I'm pulling these to. Pull this out, find your brake line, bring it back. Now finally, it's hard to see this one here, but here it's easier to see this little blue arrow that they puts. Just look for them right in the middle of your crop region, and now that allows me to move this closer and actually finally get rid of the space between these two. If you do it too quickly and slam them back together, they will reattach and expand again. So you have to be really careful when you're doing this, when you want to get them really close together like this. That should be good enough to fit on my sheet. Once I do all that, I always like to go back and hide my crop region because I find it to be a little distracting. I don't really need to see it. Again, I might adjust this first floor out here. I'm not going to go over the placement of every brake line, just look at your final deliverable to see where they all need to be placed. Now I do need to create a ceiling in this elevator machine room. So a couple things I need to do. If you look at the final deliverable, this wall does. Right now we have this wall going up to the second floor with the 0 offset. It actually needs to stop somewhere below this stair. I find if you bring it right down to the top of concrete patio, that's a perfect height. It just misses the stair. We also don't need that top of concrete patio label, so we can hide that in the view. That's not relevant to this section. So I'm going to go back to the first floor plan, and I'm going to go to architecture, ceiling, and I'm going to use a compound ceiling, but I'm going to change that to what my instructions say, which is a gypsum wallboard on metal studs. So it's got gypsum wallboard to both sides, because you can actually, as you're walking up the stairs, you can see the top of this ceiling. So we're going to do gypsum wallboard with a 1-inch finish on the bottom and a 5/8 thickness on the top and a 2.5-inch metal stud. So I'm going to start with this I'm going to start with gypsum wallboard on metal stud. So I'm going to change my type there, edit type. I'm not actually going to rename it because it is technically gypsum wallboard on metal stud. I'm just going to edit structure. The finish below is 1 inch thick. I'm going to insert a layer, move it all the way up to the top, change it to a finish 2 layer, and again change that to gypsum wallboard and make that a 5/8 inch thickness. That is the same, and then what is this? This is 2.5 inches. Yes, 2.5 inches. That gives us a rated assembly. We're going to hit OK. Hit OK again. The way that ceilings work, the placement of ceilings, you'll notice there's 2 ways to place a ceiling: automatic ceiling or sketch ceiling. A lot of students do this where they're not really paying attention, and as I move my cursor around, it'll find the extents of the room, or basically it'll find the boundaries of 4 walls. And if I click there, it'll automatically create the ceiling. And you can see that the height offset right now is set to 8 feet. You can also sketch a ceiling. So you could do, if you wanted to do a freestanding ceiling out in space somewhere, you could do that, without it, and you could sketch the boundaries. I'm going to do an automatic ceiling, but I'm going to click inside the mechanical room. Now you'll get one of these warnings. Obviously, the ceiling that's placed 8 feet above the first floor is not going to show up in this drawing because it's above the cut plane. So that's what that warning is telling me. I can't see the thing that I just created. What happens is a lot of students don't see anything and they start clicking multiple times, and you'll end up creating multiple ceilings. So to see that ceiling, I can simply go to my stair section here, and there's my ceiling. I'm going to set that ceiling to be 11 feet above the finished floor. So what I'm going to do, for now, I'm just going to bring this down. I'm going to use my align tool, and I'm going to align the top of this wall to the top of this stud in the ceiling. Now the problem with the automatic ceiling is this ceiling actually needs to come all the way over to the edge to get this stuff to clean up the way it's shown in the final deliverable. And this edge has to come into at least the stud layer. So what I'm going to do is I can select the ceiling in this view, edit the boundary, and it's going to ask me, hey, you're in a section, you can't edit the boundary in a section. So I'm going to say, let's go to the first floor plan. And what I have to do temporarily is turn my detail level to medium. And you can see that now I can see those stud layers. So I can align the edge of this to the outside edge of the stud. And on this one, I'll do the inside face of the stud. I'm not sure. I could probably do the inside face on that one as well. We'll see how this looks. Hit the green check mark, go to our stair section, and now that they are overlapping like that, and actually I think I'll need to pull this up to that level so that it cleans up the corner. And now I can go to the modify join, and I can join my ceiling to my wall, and you can see now that it cleans that all up. And I can do the same thing here, join those together, and it cleans all that up so that the stud layers kind of flow into each other and the gypsum wallboard flows, just the way that it would be built. So that's how you do the ceiling for this particular assignment. To complete the rest of this assignment, it's essentially documenting these two details. So as you can see, this 3D view here looks different than the final deliverable. And I mentioned this before, we can only get so far with the 3D elements. We can't actually manipulate these 3D elements to do exactly what we want them to do. And neither would we. It would take too much time to do that, and it's just not necessary. So what we're going to do, when you get to this level of detail in a Revit model, a lot of times what you're going to do is you're going to create the view in 3D, and then you're going to place two-dimensional elements on top of the 3D view to finish up the high levels of detail. It's just the way it is. It just takes too much time to make everything perfect in the 3D drawing, which again, it's not really necessary. So I'm going to start by setting my scale again. This one is 1.5 inches. I believe the other is inch. I'm going to go ahead and adjust these. We don't need to see the top of concrete patio, so I can hide that in view by element. This one, I want the second floor designation to be over on this side where it's less cluttered. So I'm going to check off that box. I can pull it away from the drawing just a little bit, and then I can select it again and turn off the symbol on that side. So I'm going to start up here where the slab essentially at the top of the stair needs to turn into another nosing. So we can't make this detail happen in 3 dimensions. We have to only do it in 2 dimensions. So what I'm going to essentially do is draw over my 3D floor with a filled region that looks like concrete, and then I'm going to hide the actual 3-dimensional deck behind. So here's my 3-dimensional deck. Before I start that, I do want to point something out. In my slab, you can see the flutes of the metal deck. You might be able to see that, you might not. If you don't see that and you simply see like a dashed line, what's happening is your floor is spanning in the wrong direction. These flutes run parallel to the span. So how do I fix that? If you do not see this, what you need to do is you can select the floor, but you need to go somewhere where you can edit the boundary. So I'm going to go to the second floor plan, edit the boundary, and you'll notice that one of my boundary lines, one of these pink lines, has this special icon where it's kind of the boundary line, it's surrounded on 2 sides with these short lengths. That is the span direction indicator. So this one says that it's spanning left to right, which is what I want. If you could not see those flutes in your detail, it means that this is probably on one of your vertical lines. To change that, you have to come up here to your contextual ribbon and click span direction, and then simply choose any horizontal line. And in fact, what I'll do is I'll set this back, or I'll set it to vertical, and I'll show you that in my section now, I don't see the flutes. I've changed the direction of the flutes by changing the span. So again, if this is what you saw initially, you can go to your second floor plan, select the floor, edit boundary, span direction, and simply click any of these horizontal lines. It doesn't matter which one. Hit the green check mark, and you should, in that stair section, now see the flutes. So if you look at our final deliverable, you'll see that the concrete comes out to the nosing, or I should really say it comes out to the riser, and it's kind of a thickened edge, and then it goes back to one flute. So what I'm going to do is I'm going to come in here to my Annotate tab. All two-dimensional work is done through the Annotate tab. So I'm going to annotate, and I'm going to do a region, a filled region, and I'm going to check my type, and I need a concrete filled region. There is none, so I can choose any one of these. I'll just choose the top one, diagonal crosshatch, edit type, duplicate, and we're going to call this concrete, and we're going to leave everything the same except the fill pattern. We're going to change that from diagonal crosshatch, and there's a concrete hatch. It is a drafting pattern, so it changes depending upon the scale. So hit OK. Hit OK again. And now I basically just have drawing tools. So I'm going to set my line style to, let's do this in a medium line, and I'm going to use the Pick Lines tool. So I'm going to click on the top of my slab, bottom of my slab, back face of my riser, and then I'm going to trim those together. And I'm going to come back to this flute. Now yours might be in a different location, doesn't really matter. I just want to show sort of one flute here. That, unfortunately, I can't pick the flutes because of the way that Revit works. So I'm just going to come in here, and I'm just going to estimate that angle. And then the height of this is 2 inches because this is a 2-inch metal deck. So I can come in with my line tool. I can set my offset before, and I can simply click on this line and trace it, and it'll offset the line 2 inches. Now it's offsetting it downwards, so when I go right to left, it's going to do it on the underside, just like when I create a wall. Hit the space bar, I can flip it up, and now that's in the right plane. I can trim these lines together here, trim these lines together here, and I'll go back to my line tool, and I'll just go outside of my crop region a little bit just to guarantee that this shows up properly, and then I'll trim all these lines together. I've essentially, here, let me escape, and I'll select these so you can see them. I've essentially created this shape out of a filled region. I'm going to hit the green check mark, and now I have a concrete filled region on top of my 3D drawing. So this is just 2D. This would not show up anywhere else but this view. You can obviously see that this causes issues, right? Because like my actual 3D slab is still back here, and it's sticking out further than I want it to in all of this. So what I can do here is simply hide it in the view. I don't need to see it in this view. And there we go. I can turn off thin lines just to check out my line weights. And essentially that's how I'm going to do the risers here. So the 3D risers aren't technically correct. I could probably go in and maybe make my own riser profile and all that jazz, but that's a lot of work. Sometimes it's easiest just to draw things in 2D. So what I'm going to do is I'm going to do the same thing. I'm going to go to Annotate, Filled Region, Edit Type, Duplicate, and I'm going to call this Steel, and I'm going to change the drafting pattern. Is there steel in here? There is already steel in here. I don't even have to create a drafting pattern. Hit OK, hit OK. And I'm going to, again, pick lines. I'll pick that line and this line. I'm going to switch back to thin lines. That's the TL command. Choose that line, because again, this has to be in one enclosed loop. Now, if you look at the final deliverable, you'll see that the pan, or the riser, actually creates this pan. It comes up to the nosing, and it comes back, let's say, an inch. So I'm going to choose that line, and then I can set this riser we created, we edited that to be 1/8 of an inch in thickness. So I can simply offset this downwards 1/8 of an inch. And then let's do a 1-inch offset from the back side here. That just gets me, well, that kind of screwed me up. It trimmed that one back. So now I can trim this, see that line to there, then this line to there, and that line to there. I can get rid of my 1-inch offset because that was basically just a layout line. And now I can trim this line to here. So I kind of have this 7 shape for my riser, and I can hit the green check mark, and now I have a steel riser. Here what I can do, I'm going to do just a flat piece under the concrete pan. Well, first of all, before I do that, what I can do is I can select that filled region, I can copy it, that's the CO command. I'm going to use it, grab it right from the nosing, and I can plop it right down on top of that. And the way that filled regions work, again, they also mask any 3D geometry behind it. So now I could come in and do this horizontal pan. I'll do that again with the region. I'll use my pick lines tool. I'll pick that line, set my offset up here to 1/8 of an inch, pick that line again, pick this line. Oops, I put in an offset, of course. I don't want the offset. So I'll go back to the pick line tool. I'll go back to the pick line tool, type in a 0 offset, choose that line, and here I'll choose that line, and again, now I can trim everything up. So I just have that flat piece there, hit the green check mark, there's that pan. Again, why redraw anything? I can copy that. I'll use this nosing down to this nosing, and it places it down there, and the rest of it's outside of the crop region, so it crops it out. So to further detail this out, you can see that the stringer abruptly ends right at the top of the stair. And you can see in the final deliverable that is not what I want to happen. I want this stringer to sort of turn into this horizontal portion. So what they'll do is they'll take the C channel, and they'll take a small section of C channel and they'll weld it, at this angle to the stringer. And then as you can see with the note, they'll cap the end with a 1/4 inch steel plate and they'll grind everything smooth. So we have to create this extension here. And to do that, we're just going to use detail lines. Detail lines are just two-dimensional lines drawn in Revit. You could draw anything with detail lines in Revit, just like you would in AutoCAD. I'm going to come up here to detail line. Now I'm going to turn thin lines off so I can actually see my line weights here. These metal pans that I created, these risers, their line weights are a little off. I'm not going to worry too much about them. Actually, let's think about this. This could get a little complicated if I wanted to fix my line weights. Let's fix this one. We'll edit the boundary, and here it's being cut. I think these are medium. Yes, these are medium lines. What I'm going to do is this outside edge is going to remain medium, but where it touches the concrete, this one and this one, I'm going to change those to thin lines. And then this one, I'm going to, can I split a line? Let's see if I can split a line. I can split a line with the split tool. I'm going to pull that down to there. I can pull that line down to there. And then this line here, I can also make thin. So that way, the things that I'm actually cutting through, right? And actually down here, what I want to do is this can be thin. I'm going to split this line right there, and I'm going to change that to thin lines. That way my cut line for these stairs is medium, and then everything kind of where two materials touch within the cut, I'm going to leave as a thin line. So if I did that, let me see what that looks like. That looks much better. And now if I come here to this piece, edit the boundary, I'm just going to make this line and this interior line thin lines. Thin lines, there we go. Now that's only doing that on that one. Obviously these are not like blocks. I would have to come in here and edit this one. So I could edit this boundary, select that line, and make that thin. I would have to do that up at the top again. So back to my detail lines. I need to create this piece that comes out straight. So I'm going to go to detail line, and for this, because I'm seeing this in profile, I'm not cutting through it. I'm going to stick with thin lines as my line style here. I'm going to pick lines, and again, I'm going to set a 2-inch offset, because if you look here, I'm trying to draw this horizontal line, and if I pick this line with a 2-inch offset, it's just going to draw a line right here. It depends upon what side I am on that line. So again, I'm going to be on the upper side of that, pick that line. There's that 2-inch line. Now I can also draw with the 2-inch offset the vertical line, because this vertical line is still here. So I can pick lines, 2-inch offset, pick this line. So there's the extent of that. I can trim that to that, and this one I can't trim, but I can, where is it? Is it all the way over here? Yeah. I can pull this back until it touches the stringer there, and then again, detail line, pick lines. I'm going to pick detail lines. I'm going to pick this line here, and now I can trim this line to there. I've already trimmed those together. Now this one I need to split between those two, so I can modify, split, and now I can just pull this down here, because this, again, this is behind the concrete now, so I wouldn't see that through the concrete. Now you're going to say, well, you've still got these lines here because this is the 3D element. You might say, okay, I can do the same thing as I did for this. I can just hide in view, right? Problem is that the stair is part of that. And if I don't want to have to go back in here and redraw the stair with a concrete filled region, again, that's too much time. So what I could do, instead of hiding, I'm going to undo that. I'm going to use the line work tool. What I can do with the line work tool, so that's modify line work tool right here, or you could just type LW. I can modify the lines that make up the edges of my 3D objects by using this line work tool. This only works on 3-dimensional objects. So the way that this works is I choose the line style I want to make the line turn into. In this case, I want to completely hide these lines. So I have to use invisible lines. Now you'll notice this on this this filled region, or really any of these filled regions, I cannot come in here. I cannot actually hide, or I can't change the line style of filled regions or any 2D objects. I can only affect change on 3D lines. So I'm going to come in here to this vertical line and I'm going to click and it disappears. Now, if you might have to zoom in or kind of move your view around a little bit, you'll see these little artifacts here. So this is just another piece of the 3D geometry. So if I click that again, now it's pretty, there's two little dots here, but those I'm not going to worry about. They won't even really show up in my drawing. This line here, I just need to get rid of this little piece. Unfortunately, when I click on that, and actually I have to do it twice again, it's going to make the whole line disappear. Sometimes this happens. So now what I can do is I can just come back with annotate, detail line, thin line, and now I can just trace right back over that thing and put it back in place. I'm going to do the same thing up here with this baluster, because again, that baluster bottom didn't work out very well. So I'm going to just trace over that from that point up, and I'm just going somewhat past my crop region. It doesn't really matter. I'm going to choose that intersection, and now I'm going to come in with my line work tool, invisible lines, and I can hide that line and I can hide that line. And now that I zoomed out, this line's still sticking down. So again, line work, LW, and because I traced that already, I got rid of that whole thing. Now the dash lines on my stringer just to indicate basically the edges of the C-channel beyond, as well as that 1/4 inch plate that's on the other side. So there, we wouldn't see them again, because if I think about my stair, right, I'm kind of, so this section is looking right here. So what I want to show is that, you know, the C shape beyond, I'm just going to show that in dashed lines. So what I can do here, now I know that that plate's called out at a 1/4 inch, so I'm just, you know, I think my web on my channel is a little bit thicker than a 1/4, but again, at this point, it doesn't really matter for the drawing. This is going to be what it's going to be based upon the C10 by 12. So I'm going to go detail line. I'm going to change this to hidden. I'm going to pick lines and I'm going to put in a 1/4 inch offset, and I'm just going to choose those lines. And again, if I hover over this thing, if I can find it, yeah, you can see that the web is actually thicker than a 1/4 inch. I think in the final deliverable, I may have shown it thicker than a 1/4 inch. Detail line, pick lines. Now it won't seem to find that, so let's just put in a 3/8 offset. Do that for the top and bottom here. We'll do that for this section, and then we'll do a 1/4 inch because that plate really is a 1/4 inch. Then again, we can just trim those all up. It's a little bit more than 3/8, but close enough. Don't forget to add these steel support angles. Again, these are just detail lines. These are nothing more than a bunch of lines. And once you draw one, and again, I don't have any real dimensions in, just make them look similar. You can put in this little piece of gypsum wallboard at the top of this wall, put in the dimensions, and put in the notes. I'll show you one note. Let's see, what's my top one? Actually, I'll just do the steel support angle. It's a short one. To do notes, you go to annotate text. You want to choose the 2-segmented leader in your contextual ribbon. Actually, I should back up. Make sure that you're using 3/32 Arial is your type, or else your text is going to be too big. Then check your leader type. All of these are going to be on the right side of my drawing, so the leader at the top left is correct, and because it's on the right side, it's going to be left aligned. So I'll just throw this little steel support angle in here. So the first click is where the leader goes, the second click is where the landing starts, the third click is where the text starts. So I'm just going to do this all caps steel support angle. Now, this happens to a lot of students, and it happened to me, right? I just created that text and it disappeared as soon as I finished it, and I got this warning. None of the created elements are visible in this view. We've seen that before. The reason behind that is different than anything we've seen before. So I'm going to hit escape. When you are in a detail view and you select the crop region, you'll notice this dashed crop region outside of my crop region. That is the annotation crop. The inner one determines what 3D, actually even 2D lines and 3D geometry that gets cropped out. This outer one determines what annotations get cropped out, and if you pull that out far enough, you'll see that your text will reappear. So you may just have to kind of pull this out. Again, this does not print, so it doesn't really matter how far out you pull it, because once you deselect your crop region, it will go away. Now don't forget to put in the vertical break line here and these two break lines. I'm not going to go over that. I already showed you how to do break lines. One thing I have it wrong in my final deliverable, I'm going to have to update that, is the arrowhead type. So we're going to edit this type. That should be a 30-degree filled arrow. That is an architectural standard. So we're going to choose that. That looks much better. I will update my final deliverable accordingly. And like I said, a lot of this is just 2D lines drawn on top. I am not going to show you how to do this detail here. Again, it's pretty much all the same that I did before. All of these treads, the stringer extension, how I achieved all that is pretty much the same. The one exception is the anchor, this expansion bolt, where I'll show you where it exists. You know how to load it in. So go to insert, or we could go to annotate. It doesn't really matter. We'll go to detail component. Now we don't have that in here, so we're going to have to load family. This does take some knowledge of the divisions. Some of you may have already had some classes where you talked about the, I believe this is CSI format, or maybe it's master spec, I can never remember. They're usually broken down by kind of material. So this, an anchor bolt is metal. So it's in the Division 5 metals, and it's in this weird folder here at the top, common work results for metals. And then the only thing in there is metal fastenings. And then you can find bolts. I always like to click on one of them and then just use my down arrow, and then I can just quickly cycle through these and I can look at this preview, and you can see all the different things that you can insert into your drawings. And these are very useful, these detail components. They're two-dimensional components. They're much like AutoCAD blocks, only they're just like anything else in Revit. They're a family, and they can have types. So we can have an expansion bolt side, which is what we want to load. So we're going to load that, and it can have multiple types that are all different sizes. So let's open that, and there we go. We can see that we have this expansion bolt. Now I don't remember what size it is. It is a 3/8 inch bolt, and that is the default. Otherwise, if it was a different size, you can see here that there are already several different types in here that are of different sizes. For this, I just need a 3/8, so I'm going to set this to 3/8, and I can place that. Again, spacebar rotates these 90 degrees. I can place my expansion bolt where I need it to. That little tab at the bottom, again, that's just a series of lines for this detail. So the rest is just, again, placing some details, getting these on sheets, naming them properly. So to wrap up this assignment, we just have to do a couple more things. One, we have to put the elevator in place. That is a Revit loadable family that I've uploaded to our course homepage, so you can download that. I've already got that open here. So I've just gone ahead and opened the family. It's essentially a door with a fancy floor plan symbol. If you hit the load into project and close, because we don't really need to edit this at all, you'll have it available in your project. Now I'm in the first floor plan and I have it loaded. It's an architectural component, and I'm just using, I believe, the default type that comes up, which is a 13-person wide car. So there's several different types within here. As you can see, it's wall based, so you have to click on a wall to place it. I'll place it right here. You can see that my dimensions were centered and it's inside. You can flip this thing around just basically like a door because it acts extremely similar to a door. So on the first floor, the door faces the stairwell. On the second floor, so I have to go to architecture, component. On the second floor, it opens on this wall. I can't seem to get it on the right. Oh, there we go. If I just move it there. So this elevator cab will have a front and back door. So you enter on one side on the first level and you exit on the second level on the opposite side. Finally, the last thing I'm going to show you is how to create the 3D view of the stairs. So what I'm going to do is go back again to my first floor plan. I might close some of these. I have a lot of things open right now. You can close those all by going to your quick access bar and clicking this close inactive windows button. And it kind of cleans up some of your views. I'm going to go to the view bar, the 3D button, but instead of clicking the little house, I'm going to click the down arrow and I'm going to choose camera. You can see I don't have any instance properties for this or types, but I do have a couple options up here. I have the offset from the first floor, so typically this is going to be 5'6". The eyes of a human are generally 6 inches below the top of their head, so this is representative of a 6 foot tall person. You could adjust it maybe a little bit shorter if you wanted to, but this is pretty standard for 3D rendering views. I do want it to be an actual perspective. I'm going to place my camera somewhere around here in the entryway, so click there. The second click determines the view plane, and the view plane has to be outside of what you want to see, so I'm going to click somewhere outside of this building so that it shows everything beyond the windows. And then it creates that view, so you can see that here. I can take my crop region and I can expand that over. Maybe I just want to, I forget what's in the final deliverable, but let's grab part of the entry door. I want to get to the bottom of the stairs, and then I believe I have shown just enough to grab the elevator door, and then I pull this up, I think above, yeah, right up about there to see the whole stair. I can set my display option, my graphic display, to consistent colors. And that's all we have to do to create that 3D view. And this is, again, this is one of the biggest benefits of Revit, is how quickly, once we've modeled the drawing, that we can pull, drawings, views, sections, whatever we want out of the drawing. That wraps up all I'm going to show you in this video tutorial for this assignment. Thanks for watching.